Okay. Uh, Again, welcome everyone. And now next we will talk about more details about our TSCC 2.0. And here is today's outline. And first we will review our systems, and I will then tell you how to log into our TSCC 2.0. And I see most of many of you have sent your SSH public key for login, and I will tell you how to log in our slides. And of course, later we will have a hands-on session. So during my introduction, you can just listen what I'm talking about, and maybe I will show you some command or some examples, but you don't need to practice with me, and we will have a hands-on session open later. And after the login introduction, I will talk about the file system 2.0, which is about our new home file system, new lecture file system, and also other storage places, and how to transfer your data from your current TSCC storage to the new storage. And then I will introduce the software environment, which is about how to use our new modules. And the last part is the most important part of today's introduction, which is about how to use SLURM to submit and monitor your job. And I will also give you several examples before we enter the hands-on session. Okay, let's have a system overview and login session. And this is the general TSCC 2.0 architecture. And we have many new stuffs, and actually almost every part in this this figure is new. Like we have a new lecture file system, we have a new home file system, and we have a new switch connecting your nodes and our storage and the internet, and we have a new job scheduler, and we even have a new hotel cluster nodes. And then thanks to Dr. Ludmila Alexandrov's group, and we will have even more hotel nodes than we currently have. And almost everything are new, but what are the old? Yeah, the first thing is you will keep your current Condo nodes to our TSCC 2.0 as long as it's still in the warranty. And of course, our TSCC support team are still the same, and we're trying our best to provide the same level of support compared to the TSCC 1.0, and we are here to help. And so feel free to reach out to us if you have any questions or need help. So as TSCC users, you may already familiar with this how our condo and hotel program works. And as a condo users, you purchase your compute or GPU nodes, and then join the condo program, and you can run your simulations or your code on either condo or hotel nodes. And as the hotel users, you are purchasing computational time, and then you run your simulations on the hotel nodes. So in today's TSCC 2.0 test cluster, you are all invited to the test clusters. So we will open a hotel nodes for you to for some basic tests, help you get familiar with our job schedulers, and learn how to transfer data, some tests like that. And in our hotel program, we have 30 CPU nodes plus one P100 GPU node. And in the future, our hotel program will add 36 more CPU nodes as well as one A100 GPU node. Okay, so here is our new operating system, and we will have a new Rocky Linux 9 operating system to replace our current CentOS 7, and this is only because the CentOS 7 is out of date, and we found a Rocky Linux 9 is what we need, and I mentioned this in our April TSCC 2.0 training, and just a reminder, if you need to know some details of our TSCC 2.0, you can also refer to our training slides and the reports in that workshop. So the slides I have introduced are all about some basic information about TSCC 2.0. Next, we will begin to learn something new. We will begin with the login. So we have a new host name for our TSCC 2.0, which is as I highlighted here in red, login.tscc.sdsc.edu. This is very important, as when you log in, you need to know the host name of our login node, and still on the Linux or Mac OS, you can open a terminal and type the SSH command to connect, and on Windows, you can use mobile term or party or some other GUI SSH clients to connect to our login node. But note that the authentication method has been changed for the TSCC 2.0 test clusters. Now we only support the SSH key plus the dual for logging. The dual is an authentication, two-factor authentication method, and that's why we ask you to provide your SSH public key in advance before the workshop, and we will help you set this up so you can log into our cluster. And here is the exact command you can use when you are opening a terminal and trying to log in. You can just type SSH username at our TSCC 2.0 hostname, login.tscc.sdsc.edu, and then since it's logging by SSH keys, you will see you probably will see you need to enter the passphrase on your private key, and we recommend you have a very strong passphrase on your private key. So after you enter that, you will see a dual two-factor login process. So you can either you will see on your screen you have two choices, like a dual push or the SMS passcode. So you can choose either one and then enter the relative information to login. And I also included the two-step login instructions from the UCSD link that which I highlight here. And if you haven't been you haven't been used a dual before, you can take a look at this link to learn about how to set up dual. But I think most of UCSD users should have known this before you use TSCC. Okay, so if you want to generate a SSH key, this is the details about how to generate it and how to install the private and the public keys, and how to use the SSH agent or the keychain to avoid typing your private key password repeatedly. So I will skip this, as I think I have mentioned this in our previous slides, and you already created your key, but feel free to let us know if you need further assistance about this. Okay, so loading wise, we have done about that part, and next I'm going to introduce our new file systems under TSCC 2.0. So here's the overview of our new file systems. We will have a new hardware. We will have a new hardware for our home file system, and each user still receive 100 GB of storage as the home directory space. And we also have a new hardware for our global Scratch storage system, and the total storage space is 2 petabyte. And of course, we still support the project storage that can be purchased from the RDS, but now there's a policy change that only storage operated by SDSC can be mounted on TSCC 2.0, and we don't accept other external mounting anymore. And last is for researchers working with the dpgap data. Now TSCC 2.0 will allow access to the dpgap data on the TSCC clusters without isolating your nodes. Okay, so let me give you more details about our new home file system. So here is the location of your new home file system. After your login, you will be at your home directory, and still 100 GB quarter. And please note this is only for the source code binaries and small input files, and not for the high performance IO through output. And please consider to use larger or local storage spaces if you have a very high performance IO in your simulations. And the last part I want to emphasize is about the data transfer. And your data saved under the current TSCC 1.0 home file system should be transferred by yourself. I mean, you will do this work by yourself, and I will introduce some tools for the transfer in my next slides. But here please note that you will be the one to transfer your data from your TSCC 1.0 home directory to the TSCC 2.0 home directory. Okay, so the Lustre file system, the new Lustre file system. Here as I highlighted in red, the Lustre file system path is /tscc/lustre/scratch/your username. Please note this is a different, looks different from your current Scratch TSCC 1.0 Scratch system. So please remember the location, and how about the quota and the purge, and we still, please note, we still have a 90-day purge policy on our new Scratch file system, and this file system is good for high performance IO operations, but not for the extensive small IO. Still same for the new home file system. You will be the one to transfer your data from the current TSCC 1.0 to the TSCC 2.0 Scratch space. And how about our projects and the local storage? You will still have your project directory, and you can purchase yours from our RDS SDSC RDS group. And the local Scratch is also available when you have a job running on that node, which is now different from before. The new path of our local Scratch is /scratch/your username and scratch job underscore and then the slot job ID, which is good for writing small files. And remember, anything you put in your in the local scratch will be purged at the end of the running jobs. And how about our current TSCC 1.0 file systems? How about our current home and larger file systems under TSCC 1.0? They will be mounted on TSCC 2.0 for data transfers later, but not today. We will have this done later. So yeah, now you know that you will be the one to transfer data from your TSCC 1.0 home and scratch to TSCC 2.0. Here I listed something you should consider during such data transfer. First is please determine which files to transfer. Yeah, such as any necessary source code, input-output files, portable programs such as singularity images and any other binaries that are portable. And please also remember to back up your important data to your local storage. And please do not transfer any previously compiled software, including the Anaconda, Miniconda, or Member. Those software I do recommend you to restore in the new home file systems. And please don't transfer those unwanted or temporary files. And if you have a version control report, maybe you can start you can use the git for the version control rather than transfer those records directly to the TSCC 2.0. And so please carefully think about what to transfer. This is especially important when you have like hundreds of gigabytes or even terabytes files saved in your current TSCC 1.0 larger file systems. Please think carefully whether to transfer them to TSCC 2.0 or not. Otherwise, you might need to you might find yourself transferring those unwanted files, but then later you won't use them. And of course, if you have any questions about what to transfer, please email us and we will help you to decide if give you some suggestions. And of course, you are the one to make the decision. And so how about those tools we are using? Where we are supporting some common data transfer tools such as the SCP, rsync, and SFTP. In the next few slides, I will give you some details about how to use them. So first is the SCP. Oh yeah, sorry. Before that, please note, I just want to add one slide here is which is very important for before you can transfer your data. Remember that now we only support the SSH key plus dual for the transfer. So if you want to transfer from the TSCC 1.0 to 2.0, you will need to set up another SSH key pair for you to transfer data between 1.0 to 2.0. So that's why I'm adding a slide here. You're telling you how to generate such SSH key pair. So that what I have here, SSH-keygen is the command for you to generate a SSH key pair in the command line interface. And I would recommend you choose the key type of ECDSA as shown in my example. After you run this command, there will be a key pair created in your .ssh directory under TSCC 1.0. And of course, make sure you have a very strong passphrase on the private key on you. And also install the private key, that part, since you already generate that private key under that .ssh directory. You don't have to move it to somewhere else. Just keep it there, but you need to add the content of the public key to the authorized keys under the TSCC 2.0. So that's how the the key should be set. So once you have set the SSH key, you can then begin to transfer data with the tools I just mentioned. For example, the SCP, you can just first log into TSCC 1.0, and still the login name is tscc-login.sdsc.edu. Once you log in, please note, if you have a huge amount of files, or like hundreds or even thousands or millions of files in one directory, please consider to compress those files or directory into a single tar file instead of transferring many files simultaneously. And so please compress those files into a single file. Then you can use the SCP command to transfer the files. So SCP does support the transfer directory, but I do recommend that if you have too many files, you please compress files into one single file for the transfer. And if you have a very large amount of data, please consider to transfer them on the data mover node, which is TSCC-DM1 under the TSCC 1.0, and then you can begin to run those transfer commands. And after it has been transferred, you can then log into TSCC 2.0 and extract the tar file. And I list the command here. So rsync is similar to the SCP, and the same for the STP command, SFTP command, but there's some minor difference about how to use them, and I'm not going to introduce them in detail in today's workshop. If you need to know more information about how to use those commands, you can refer to our transition user guide or their menu page. Of course, during the TSCC 2.0 test class period, you can transfer your data from any other external sources, still using those commands I just introduced, or you can download a link from a website with the wget command. And for now, the globus is not ready yet. So, we will have it done later, but not now. And also you can use some GUI tools to transfer files, like the mobile xterm, the GUI in the mobile xterm, or the FileZilla. Okay, so next, I'm going to talk about some new features of our module environment. We have upgraded our environment modules. Now we use LMod, which is a newer, and I think it's more powerful than the current TCL module. So what's the major differences here? So under TSCC 2.0, so not all available modules will be displayed when running the module available command without loading a compiler. So the new module command, module spide, is very important and the key for you to locate the module you want to load. You can use the module spide and then add the software you want to search, and on your screen you will see the the module is telling you how to load the software you want and which modules you should load first. And the module paths are different for the CPU and the GPU nodes now. And you can find that almost every module file has its CPU version and the GPU versions for using on the CPU or GPU nodes. And here's the overview of our upgraded software stack. And we have newer compilers like GCC 11, 10, and 8.5 compared to our current compilers on TSCC 1.0. We have a newer MPI implementations and newer programs under the CPU and the GPU stack. And most packages are built and managed by spec so that will be easier for us to maintain and update our software stack if needed in the future. And I just want to add that if you want to create your own module files, you can still do the same as if you are using the current TCL modules on TSCC 1.0. And I just gave the example of a simple module file that I test and works on our current TSCC 2.0 test cluster. But I won't give you too much details about how to create your own module. So I just list here for information. And that's about our new software stack and our new environment module. And the next part, I think, is our key session of today's workshop, which is about how to submit and monitor jobs with the new job scheduler, which is SLURM. So now we have a SLURM job schedulers, and that's I think that is the biggest difference TSCC users will notice on TSCC 2.0. Now if you have been using our cluster for years, you might be familiar with our PBS job scheduler, and then you begin to use a new job scheduler. You might want to know how hard it will be for the new job scheduler, and what can I really handle it? And that's what we're going to talk about in our next few slides. So be with me, and I think everything would be new, but it's not that hard. So very straightforward. But here I want to add a very important note for the test cluster users. In this workshop, as well as the following test period in the next couple of weeks, you will find that we are running jobs, but those jobs are not for production runs for your research work on the test clusters. So that's, in other words, we do not expect you to run your research on the test cluster. The main reason is we have very limited computational resources on the test clusters, and we only have 30 CPU nodes plus 1 GPU node. On that GPU node, we only have 4 GPU cards. So we don't want you to run your research work here. So please, if you still have research work, please go back to the TSCC 1.0 during the test period, and then finish your research there. But what you can do on the test cluster is you can get familiar with yourself with the SLURM. You can begin practice some SLURM SLURM jobs, and you can, if you have a large compilation to do, you might signal to start a interactive job to install software. So you can finish your software installation smoothly on the new home file system. And of course, you are welcome to have some small tests, only for tests to make sure that your code or your simulation can work. So that's the purpose of our job runnings on the test clusters. So here is an old slide from my TSCC 1.101 workshop. Just remind you that please don't run your computational programs code on the login nodes. So even for very simple tests, and we have compute nodes. So please start a job to run simulations and to run your code. Okay, so since we have a job scheduler, you may already know that we have a queue, we have job queue in our current 1.0 PBS job scheduler. In SLURM, we also have a similar queue, but we call partition on partition for you to identify identify the computational resources. So currently there are two partitions available during the early user test period, and the first is called the hotel partition, which is specified for the CPU resources, and the other is called hotel-GPU, which is for asking GPU resources. Besides the partition, now we have a new term called QoS. What is QoS? So it is quality of service. It's a term used in SLURM for each job submitted to SLURM. This QoS can affect the job scheduling priority, the job pre-exemption, and the job limits. And we will set up those parameters for each QoS before you can use it in your job. And the QoS now available for the test clusters are the hotel and the hotel-GPU. And in your jobs, in your job on the TSCC 2.0, now you must specify the QoS with either hotel or hotel-GPU in order to let the job run. Okay, so we have two partitions, and here is the current partition configurations. We have a hotel queue, and the maximum work time is 48 hours, and the max jobs submitted per research group is 192, and the max CPU processor you can use is 128 per group. And how about the hotel GPU partition? The max time job is 12 hours, and each group can run at most one job with one GPU card. So that's the current partition configuration. And once logged into the TSCC 2.0 login node, you can use some SLURM commands to find more details about the partitions. Like the one I'm showing here, sinfo, will give you more information on the partitions. If you type sinfo on the login node, you will find the information about the hotel and the hotel GPUs. So you will see that in this example, when I was running the sinfo, there are 30 hotel GPU CPU nodes in total, as well as one GPU node in the hotel-GPU partitions. Other partitions we here it has zero nodes at the moment. And also the next command is critical to find your new allocation names. And under TSCC 2.0, we will not use the original allocation name, but instead each user, each group where has a new allocation name for each allocation. This as account manager command is for you to find out the new allocation name you can use. Here in this example, I use this command, then show, and then add associates, and my username, and then I'm asking the command to show the allocation name and my username, and I can find that my allocation name is use 300, and of course you will have a different allocation name than from me, so I recommend you know how to use this command, and later we will run this command to find out your allocation. Okay, so next is about the interactive job submission. That's I will try to expand this detail in the in the slides. So in SLURM, interactive job can be submitted with the SRun command. So that's a new command you need to learn how to submit interactive job. Here is the general syntax. You need to add some options. Some of them are optional, of course, but generally you need to specify the time, which is -- time or -t in the hour, minutes, and seconds format. So you should be very familiar with this format since it's the PBS job scheduler user. And then the next line is the dash uppercase N, which is short for the nodes. You need to specify the number of nodes you want to use. And the next line is the dash lowercase n, which is short for the -n tasks. The n tasks is the total number of tasks you want to run your job run on. And this is kind of similar with this is kind of similar with PPM if you're going to ask, but actually the PPN in the current PBS job scheduler is more similar to the next line, which is -n tasks per node. So that's the number of tasks per node. This option is optional to the n task option I have shown in the line above. You can choose either n task or n task per node, but the one of the will take over with the other and override the other. And the next line is for you to run the multi-threading jobs, which is a -c. It's short for the CPUs per task. It's asking the SLURM is asking you to give the number of threads per process for this when you gave this when you gave this option. If you don't you can skip this option, but if you gave it, the SLURM will know that you're hoping to run some threads job. So the next -a is short for the account. Account is actually your allocation. So remember, you need to find out your allocation name first. And the -p is short for the partition. You will give the partition name in your SLURM command, and then the -q is short for the QoS. So if you submit a job to the hotel partition, you also give the QoS hotel in your SLURM command. And if you want to enable HC11, add the HC11. And the SLURM command ends with the PTY, which is telling the which commands to run when the job starts. So if we end bash, so SLURM will start a bash session when the job starts. Okay, so here is how it looks like during the real command submission in the terminal. So you use SLURM to submit for an interactive job, specify 1 node and 8 total tasks, and then 1 hour work time, and tell SLURM you want to submit to the hotel partition and QoS, and specify your use allocation name. And the last part will be which command to run when the job starts. And please note that once your job starts, you will not see any other outputs, but you can notice that the node name has changed. Before the job starts, it's loading 1, which is the name of the loading node. But now, once the job starts, it changed to TSCC-11-70. That's one of the CPU nodes we have. Okay, another thing you can know, you can know is not the SLURM job starts in where the job was submitted. That's unlike the PBS jobs. So in the PBS job, if your interactive job starts, you start in your home directory. But now the SLURM knows where you submitted your job, and directly start the job in that directory. So here's a node to run the interactive job with MPI, and once your job starts, you can you still use the srun command to run the MPI job. It's not MPI run or MPI exec in general, but you still use the srun. But you need to give an option called -- overlap, which is required in my test in my test on the 2.0 test cluster, and then you give the number of processes to run, and then add followed by your MPI executables. And I have a example here, and that I found that if I don't add the overlap, the srun will hang. So that's why we need to add this, and the rest are the MPI executables are just as expected. Okay, so that's about the interactive job, and next is about submit a batch job. So PBS batch job examples is here, is like you use the sbatch command to followed by your job script, and then once you type this command and hit enter, the job will be submitted. So once it's submitted, it's hard to revise what you have submitted. So please be careful to prepare the job script. This is that example of the OpenMP job, and let me show them in detail. So we have a example job script, and the green section in this slides are from that example job scripts, and you can see SLURM job scripts also begins with a bash ribbon, and then followed by several sbatch line, telling the job scheduler this is the session of the SLURM job. So you basically it tells the scheduler how much resources you want and how you want to organize your output files, and if you want to send emails to yourself once the job begins or ends, you need to modify those lines here. Like here in my example, the first line is -J. It's short for the job name. This is optional, but you can give your SLURM job, batch job a name if you want. And the next several lines, -N, -uppercase N, -lowercase n, and -C are the define the computational resources this job needs. So we here in this example, we need one node and one number of tasks, but we need 8 threads per process. So that makes sure that it's an OpenMP job for the multi-threading. And the next line is the tells how much time we need for this job. And then the -O and -E defines the standard output and the standard error file. And by default, the SLURM will only give one standard file. That means that the standard output and the standard error are merged into one file by default. But if I specify both, then once the job finishes, there will be 2 files copied to the location where you submit the job. So the next several lines are just nothing but just define the partitions, the location name, and if you want the email to be notified by email, you can set up the email email preference. So in the next flash session, this is similar to what you have known already. So it tells you how will you use the resources once they are allocated. So usually we load our modules, and then we define the threads, and then we run our OpenMP session, and this is example I am giving here. So how about a GPU job? We see our MPI example in when we see the interactive job running, and we see OpenMP example already. And now if the next I'm going to talk about how to get a GPU card on the GPU node with a SLURM job script. So I highlighted some SBatch command here. See the first one is -G, uppercase G, and I specify is 1, and that means I want to ask for 1 GPU card on a GPU node, still on one node. But just please note that the task per node should be 7 on the test cluster, because on the test cluster we have 28 CPU cores and 4 GPU cards on that GPU node. So that means if we want to request 1 GPU card, we need to also ask for 7 tasks per node. And also the partition name and QoS name need to be changed to the hotel GPU, and all other stuff are similar to the last example. And then here the next is about how to load the modules and run how to run GPU simulations. And I think the last line defines how to run it. which is also done by the SLURM command. But now we need to use seven tasks per node, and then we can specify the rest of the options in the MPI executables. So in this example, we are running Ember, and I see one of the error I made, the typo I made is here we should load the GPU modules instead of the module CPU. So that's the typo I think I have here. Please correct here in the later test. So here's the slides about how to use GPU. So if you want to use one GPUs, please ask for seven tasks per node. And same as now, we also use CUDA visible devices, this environment variable to allocate GPU cards. So please don't set this value by yourself. And once your GPU job begins, you will be assigned one of the cards as well as some values in this environment variable. And we have prepared many examples for you to test our cluster. And the location of those examples is c/cm/shared/examples/SDSC/TSCC 2. So those examples are available at the moment, and you're welcome to test by yourself. But you cannot run jobs directly there because you don't have write permissions under CM shared examples. So please copy the entire applications to your own space if you want to try any of them above, and then you can modify the job scripts and then submit your back job. And we have back job script as well as input files and some example output files in each directory. Okay, so the last part I'm going to introduce about the job. SLURM job is how to monitor the job. So once you submit a job, please don't consider it's done. Please monitor your job the resources usage. The first thing you should know is where the job is submitted to, is running to, right? So you can use the SQ command, which is similar to the PBS command to let you know where your job is running and how long the job has been running, and what's the total work time limit, and which partition the job has been submitted to. So the syntax is SQ-LU user. If you want to cancel a job, you can use the scancel command to cancel your job. You just need to know your job ID. So how to find your job ID? So you remember to refer to your SQ command. You will see your job ID there. And if you want to know more details of your jobs, you can use the scontrol command, scontrol show job ID. That command will help you to get more details of your job. And if you just wish to know how long your job has actually elapsed, you can use the saccount command, and give the option -- format equals elapsed, and then your job ID to get to know how long your job has been running. And you can, of course, add the S control and or S account command at the end of the job script. So once your job has finished, you can get some statistics about your job or other details. So please pay close attention to the CPU and the memory consumed by your job. What you can do is when you have a jobs running on a compute node, you can SSH to that node and run the top command to provide some real-time review of the running system. And in this example, you'll see that you will find some the overall CPU load, as well as some status of your simulation your process. And also you can use the free command to check the total amount of free and used memory in the system. And if you are running a job on the GPU node, you can SSH to that GPU node and run the NVIDIA-SMI command to get more information about your jobs running. But note this command is only available on the GPU nodes. So, for example, in this output, I can see whether my programs are running with GPUs and how much GPU memories it has been used, and what's the CUDA version this GPU node can support. Some basic information about the GPU jobs and the GPU node. Here are some SLURM environment variables. Once your job has started, of course, you don't need to learn or to know of them. I just highlighted two for you to maybe you can consider. You may find they are useful when you add them in your job scripts. The first is the SLURM job ID. You can use these environment variables along with the S control or S account command I introduced earlier to get your job ID and get some statistics about that job. And the SLURM submit directory is for you to quickly access to where you submitted job. And here is a comparison between the SLURM and the PBS. You will see that you will find that if you are PBS job scheduler user, you see you get they are SLURM job commands that can help you to submit jobs, can delete jobs, check the job status, and check the allocation names and many other things. I just list here to make sure that you should be able to use SLURM to replace PBS once you get familiar with it. Okay, so what's next? What's happening next? So I mean, in the next couple of weeks, and we are having more trainings to help users to get familiar with TSCC 2.0, but that one will be open to all TSCC users. And each training is identical and will be a few hours long, and still focus on the storage, SLURM, accounting, software stack on the TSCC 2.0. And if we have done anything new or upgraded any system configurations or systems and added more features, we will also introduce them in our next trainings. And also, since it's longer than today's training, we will have more detailed demos, examples, and benchmark performance. And like a few weeks later, we will have the test cluster open to all TSCC users. So during this test period, your feedback is crucial. That can help us move to production sooner. And thank you so much if you can give us your feedback when using our test cluster. And as we mentioned earlier, the Condo servers will be moved after the test period, and the priority will be given to the Condo participant from today's meeting. And here is our contact method. And still, you can email us if you have any questions, and you can find more information about our test, about our TSCC website. And we also have a transition user guide available online at the moment. And just keep in mind, we are updating that user guide daily, so to make sure that we add more up-to-date information or correct anything wrong on that user guide. So that's all of today's introduction before we go to the hands-on session. Thank you so much for your attention. Thank you.